In this video, we're going to practice solving the balanced reactions from the half reactions for these two separate redox reactions. We have permanganate and chloride becoming Mn2+ and hypochlorous acid. We're going to do this in an acidic environment. And for B, we have iron 2+ and dichromate becoming iron 3+ and chromium 3+ in a basic environment. Go ahead and pause. Try to calculate out the balanced reaction for both of these redox reactions in their environment, and then come on back and we'll work through it. All right, well, if you're back, let's start with A. I'm going to go through an acidic environment for permanganate and chloride reacting. First off, let's do our half reactions of the permanganate. MnO4- is going to become Mn2+. If we want to solve the change in charge, well, each oxide is going to be a 2-. I have 4 of them, so 4 times 2, that's 8 negatives. I have 1 negative left overall, and so this must be a +7 on my manganese. So that means I need 5 electrons. 5 electrons will get rid of 5 of those positives, leave us with 2 positives after this reaction. Second part's going to be the chloride. Cl- is going to become HClO. Well, when I think about charges here, we were originally minus. Oxygen's more electronegative. We're going to generally assume it's got its charges. So there's 2 minuses here on the oxygen. Our hydrogen is generally going to be positive, so there's 1 positive. Well, this is a neutral molecule overall, so the only way to balance this out is if chloride is also +1. Our chloride went from chloride at -1 to a chlorine atom with a +1. So it's been oxidized. Manganese was reduced. It gained electrons. The chloride is going to lose them. Well, chloride used to be minus and now it's positive. It loses 1 electron to become neutral, loses a second electron to become +1. So this must have 2 electrons that are part of the product. Original chloride lost 2 electrons to become a chlorine with a +1. So we have our 2 half reactions balanced for electrons within themselves, but now we need to balance the other atoms. I have oxygens on my permanganate, and I don't have those on my products, so I'm going to add waters. Specifically, I need 4 oxygens, so I'm going to need 4 waters. In doing so, I've introduced some hydrogens. I'll need to balance those. Well, there's 8 hydrogens over on the right. I need 8 hydrogens on the left, so I'm going to add 8 H+. Now my oxygen, my hydrogen, and my manganese atoms are balanced, and the charges on my manganese with electrons is balanced. Do this for the chloride to hypochlorous reaction. Well, I have 1 oxygen. I don't have it on the other side, so I'm going to need a water. Just 1. That's going to give me 2 hydrogens. Well, I already have 1 hydrogen, so I just need 1 more. So I need 1 more hydrogen on the right to balance the 2 that came in with water on the left. And now all my atoms in my second half reaction are balanced. My electrons between the 2 reactions are not, however. I have 5 and I have 2. Well, I can multiply the top one by the number of the bottom one. I can multiply the bottom one by the number of electrons in the top one. So I can times 2 on top and I can times 5 on bottom. That's going to give me 10 electrons on both of them. So I need to modify how much of each of these I have. This is going to come out at 16H+. So doing the top here, 2 times 8, 10 electrons, 2 MnO4 minuses. In terms of the bottom reaction, that's going to give us 5 waters and 5 chloride going in as products. As to the reactants, well, 2 times Mn2+, 8 waters, and then for the second half reaction, 5 times, so So we're going to get 5 HClOs. We're going to get 10 electrons, and we're going to get 5 H pluses. Let's start canceling some things. My electrons can go away on both sides. 5 H pluses out of 16 is going to leave us 11 H pluses. My waters, I have 5 and 8, so I'm going to take 5 off each side. That's going to leave us 3 waters over here on the product side. And none of the other materials cancel. So that's going to be 2 MnO4 minuses, 5 Cl minus. All that goes on to make the 3 waters, the 2 Mn2 pluses, and the 5 HClO. Double check real quick. I've got 11 hydrogens. Over here, 3 times 2, here's 6. 5 times 1 is 5 more, so 6 plus 5 is 11. My hydrogens are the same. 2 manganese, 2 manganese. 8 oxygens, 2 times 4. Over here, I'll have 3 from the waters and 5 from the hypochlorous acid. 3 plus 5 is 8. I've got 8 oxygens on both sides. 5 chlorines, 5 chlorines. We've indeed balanced out this reaction in an acidic environment. Well, the second reaction, number 2, was our Fe2 plus our dichromate Cr2O7 minus, going on to form Fe3 plus and Cr3 minus. Split these into 2 half reactions. My Fe2 plus is going to become Fe3 plus and 1 more electron. It used to be on it when it was 2 plus. If it's no longer on it because it's 3 plus, it must have kicked it off. Our iron is going to get oxidized. Well, our dichromate is going to become Cr3 plus. Quick little math. Each oxide would be 2 minus, so 14 minuses from the oxygen. There's 2 left over, so I need 12 positives. I have 2 chromiums to spread them out over. These must be 6 plus each. So we have a hexavalent chromium that becomes a trivalent chromium. Well, that chromium used to be 6 plus. It needs to become 3 plus. There's 2 chromiums here, so I'm going to need to balance out my metals. I need 2 chromiums on that side. Each of these chromiums has to gain 3 electrons, and there's 2 of them, so that's a total of 6 electrons needed. I have to put in 6 electrons so that each chromium will gain 3 to become a 3 plus from its original 6 plus. So I split it into half reactions. I balanced the metals. We needed twice as many chromiums on the right. Balanced our electrons within each half reaction. Now I need to balance the other atoms. There are no other atoms for the iron. The oxidation step is done. However, there are oxygens in our reduction step. I had 7 oxygens on the left. I'm going to need 7 oxygens on the right, so I'm going to need 7 waters. In doing so, I introduce 14 hydrogens, so I'm going to need to introduce 14 H pluses at the start to deal with them. Now we're eventually going to convert this to a basic solution, but we continue through like it's acidic until the end where we'll add hydroxides. So we've balanced this out with the H pluses. Both halves are done. We just need to make the electrons line up. Well, the bottom is 6, the top is 1. If I multiply the top by 6, I'll have the same on both sides. I'll have 6 electrons in both half reactions. This is going to net me 14 H plus, 6 electrons, Cr2O7 minus, and 6 iron 2 pluses. All that's going to go to 6 Fe3 pluses, 6 electrons, 2 Cr3 pluses, and 7 waters. And so we had 6 times the iron reaction to get the electrons to be the same. We just needed the dichromate as we'd already balanced it. No need to multiply that one. And now we need to deal with the fact that it's in a basic solution. We don't really have the H plus around. Instead of H plus and water, we have water and hydroxide. So we're going to look at our H pluses. We're going to add that many hydroxides to both sides. So plus 14 OH minus plus 14 OH minus. This will convert these to 14 waters on the left and leave us with 14 hydroxide on the right. Now we can start canceling things that need to cancel. 6 electrons on both sides, they'll cancel. I have 14 waters and 7 waters, so 7 of them will cancel on each side. That's going to leave us with 7 waters over on the reactants. And that's all the things that cancel. So it's 7 waters on the reactants, 1 dichromate, 6 iron 2 pluses. We're going to go to 6 iron 3 pluses, 2 Cr3 pluses, and 14 hydroxides. Double check all our atoms. I have 14 hydrogens. I have 14 hydrogens. I have 7 times 1, 7 oxygens from the water and 7 oxygens from the dichromate for 14. I have 14 oxygens from the hydroxides. 2 chromium, 6 iron, 6 iron. Indeed, we have balanced this out for the reaction of iron 2 plus with dichromate, becoming iron 3 plus and Cr3 plus in a basic environment.